Hi, thanks for the invitation to share some stuff I've been excited about lately. I'm gonna, when I got to the end of my talk, I don't think I quite delivered on the vital role of learning. But I hope that what I'm really doing is starting a conversation, and we'll get to that in the conversation. And I can ramble, so I can get there eventually if I try hard. But I think this is the main thing that I'm interested in, I think, trying to chew on with a group of people who are interesting, is how learning and the complexity of software change what writing software requires from conventional wisdom, let's say. So brief agenda, I'll introduce myself. I've got 3 insights that I think are sort of big ideas from the resilience engineering. It's a 40-year discipline, so there's no way I can actually introduce it. It's also complex and tangled, and my own brain is, I'm a very divergent thinker. So all of that means I'm gonna present 3 big ideas to stimulate a conversation and not pretend that I'm gonna get you to some understanding of the whole picture. So I'll start with a slightly long story about myself, because part of my goal in coming here is to introduce myself to the community and to try to set up some collaboration. I'm keenly interested in design and resilience engineering. And in my professional life, I've been in 3 different companies trying to make this happen, and it's been sort of rejected 3 times in different ways. I was originally going to structure my talk around that, and I decided it was way too whiny. So, so I'm going to sort of skip that particular part, but some of my motivation is, I think this is important, and I think the audience I've been trying to reach aren't ready for it. So I'm going to talk, I'm going back to 1990s. I was at school at CU. I was a non-traditional student. I had transferred from Fort Lewis College. I was working at the Sundance, or I got involved with the Sundance Lab, which Mark Gross kicked off. But just before the Sundance Lab became a thing, I was taking time off from school, working with this guy, Kim Veltman. He's a world-class historian and sort of old school. And what I mean by old school is he described himself as having 15 languages, 5 in which he was fluent, 5 in which he was conversant, and 5 which he could read. And what fluent meant is that he had read all of the canons of the literature in the native language. So his bar for fluency was wildly higher than mine, and he had strong opinions about reading anything that had been translated. And he was a world expert in the history of perspective. Also an expert in Da Vinci. He wouldn't at the time have claimed being the expert, but he was right up there. He came to the University of Colorado, gave a talk that I was in an intro to perspective class, and they thought this would probably be more interesting. And I ended up, as a result of some conversations, being able to work for him. He had a big database of bibliography on perspective and no illustrations. In the 1990s, it was a DBase 3 database on a 286 computer. And I was interested in doing computer graphics and animation, and there was no coursework to be had that I knew about. You could get a computer science thing, and I had already confirmed that I had no interest in computer science. I got stumped in my first couple weeks on a Fibonacci problem in Pascal and was convinced data structures and algorithms were not for me. My career proved me otherwise, but while I was working for him, I did an animation. The only drawing tool he had was AutoCAD. And this many years later, I feel comfortable disclosing it was a pirated copy of AutoCAD 9. But it was the only drawing tool available. And so I wanted to do animation. And as a side project, I bought a book on how to customize AutoCAD. which meant AutoCAD introduced me to Lisp. I had been a BASIC programmer and a Pascal programmer, and if you look at my early Lisp programs, they're obviously somebody trying very hard to make Lisp look like Pascal. Anyway, I ended up creating an animation in AutoCAD that looked like this. This actual animation I did in 2003, reminiscing on the work that I had done in the 90s. So it's very short and not that dramatic. Mm-hmm. But it's a very simple idea. And the world expert on perspective said I had contributed something useful to the history of perspective, and he wanted me to do more animations like that. And I got a trip to Italy for 6 months out of hacking on this in AutoCAD, and in which I was building animations around the history of perspective. And the thing that was important is motion makes the geometry of a projection onto a plane clear what's happening. The introduction of motion makes that visible. And I was sure animation was cool, and I was just hacking around with it on the material that was available. Now, the other reason I wanted to show this, there's two other things that why I wanted to put this up in front of you. The animation itself, I like to brag to people. I wrote that in 2003 as a JavaScript in SVG implementation before browsers were implementing SVG. So you had to have an Adobe plugin at the time. I have not touched that code since 2003, and it still runs in a modern browser. And I'm really damn proud of that because the original work, which was done in AutoCAD 10, I can't run anywhere. I had the code. I don't have a 286. I don't have AutoCAD 10. I'm not sure if it would run in modern AutoCAD. And the work to get it running, I feel confident would be gnarly. And I'm just not quite motivated. But a little bit of JavaScript with zero other dependencies, and 20 years later, it's still running. That's kind of cool. So that's the first of the other reasons. The second is that the tool that I'm showing you here is called Federated Wiki. And the story I was just telling about dependencies, I have another page. I'm not going to tell you a lot about Federated Wiki, but what I do recreationally is hack on code in Federated Wiki. And at some point, there's really interesting stories there, and I have to have at least shown it to you while I'm introducing myself. So in effect, in the sort of late 80s, 1990, I was playing hooky from school and got to do some interesting stuff in academia. I made a decision to not be an academic. Like, I had an entry into hardcore academia, and I decided that wasn't what I wanted to do. Came back to Boulder, found the Sundance lab, and I did more programming kind of stuff. Did eventually finish my degree, although I am not notable as a student. So non-traditional student. I was at the Sundance lab. That was a really cool place to be. Another thing to tell, and the reason I have this picture, this is one of my students. I've been teaching at the rec center. If you're interested in Aikido, come to the rec center tonight, 5:30, and I'll tell you a story about Aikido. That's me taking a fall, and I can teach you how to fall. My early career right out of college, and it's sort of in college and out of college, was I started in networking. I knew as I said, I knew I wasn't going to be a programmer. Evidence to the contrary now, but I apprenticed myself to the guy who was running the network at the time. Some of you may know him. Kyle Kutchin is on the board here at Atlas, another Boulderite, and he was running the network at College of Arc and Planning. So I just apprenticed myself to him because I knew I needed networking skills. At my first job, networking. That's important for the story where I end up in resilience engineering, because it's an operations work. It's not writing code. Everything I did after that job was about writing code, starting with web applications, which I was sure was just scripting and not actually programming, until the software industry decided to promote that to actual software engineering. Web app developer for a very long time. About 10 years ago, maybe we're getting closer to 15, I started into working on infrastructure as code and platform engineering in the DevOps revolution. This whole time along, I'm an open source hacker doing recreational code of various kinds. And then in the last 5 to 7 years, I've been deeply in incidents in internet scale companies. And that's more than I really wanted to talk about myself, but I feel like I need, if I'm going to introduce myself to you, I gotta tell you some things I can talk about. So my first big idea, this is an insight from Stephen Chirac, and I love this Venn diagram because the diagram on its own communicates so much if you just stare at it for a moment. We have 4 categories, different kinds of work. They overlap, but not completely. And recognizing that there's a distinction just in looking at it, that what we imagine work to be, what we disclose if we're talking to people about our work, what gets prescribed in the rules or the job description, and how it's actually done are all completely different things. With enough overlap to be interesting, but enough not overlap to also be interesting. That sets up some of the complexity of software. And being in a community where I know design is a big thing, and having come out of the design practice myself, everything about design is in the work as imagined space. And most of business is in a delusion about imagined and prescribed, and doesn't necessarily, maybe knows that we don't really know how the business is actually done, but we don't make any rules that really honor how work is actually done. And certainly it's all challenged by how people can talk about it. I'm going to briefly dwell on the work as disclosed, because I think this is a problem that I've run into in my past 3 jobs. The part of the barrier to getting information about resilience engineering into a business leadership. When leaders are communicating priorities to the rank and file, they can't disclose insider information they know about, whatever the current financial state is, or some acquisition is in the works, and there's reasons the SEC says they can't talk about it yet. And so there's all sorts of things that constrain what leaders can disclose. And so even the prioritization about what's most important for the company is filtered by the speaker. And then the other way around, everybody down in the trenches wants to tell their boss a slightly rosier story than what's really going on, and their boss and their boss. And so by the time the news from the trenches gets all the way to the leaders, it's been filtered by the telephone game and made rosier all the way along. And the end result is that the top of the organization and the bottom of the organization can't really communicate, even if we can sit in the same room and have a conversation. So that work is disclosed ends up being a real barrier to getting a design that's well connected to reality, right? As I make a business decision, I'm doing design. So that's a big idea. Work is imagined, work is done. This one, I have tried to tell this story myself, and this conference talk, they deliver this in 4 minutes, and I can't do it that fast. So I'm just going to press play.
We start out with this view of what we think of as the world and the system, which is that we've got this code and we've got this stack and we do this stuff to it, and that connects up to the using world out there. But in fact, if we call this the system, we miss a whole bunch of stuff. There's connections of this thing, this as I'm drawing it in a bubble, it doesn't mean there's a cloud, it just means that that's the system. There's connections of this thing to a whole bunch of stuff that you use to make that work. You've got code generating tools and testing tools and deploy tools, a whole bunch of stuff that's existing out there that's really part of that. And you could say that this is the system, because many of you spend much of your time focused on those things that are not inside that little bubble there. We can take another step forward, and if we do, we'll just sort of divide all of this stuff by a line that we call the line of representation. And now we add in you, the people who are getting stuff ready to be part of the running system, the people who are adding the stuff to the system, they're doing the architecture, they're doing the framing, and they're also keeping track of the system, what it's doing, how it's doing it, what's going on with it. And you'll notice that each one of these people has some sort of mental representation of what that system is. And if you look at it a little more closely, you see that none of them are the same. By the way, that's very characteristic of these roles. Nobody's got the same representation. if we play this out a little bit further, we end up with something that looks like this. This is our model of the world. And it includes not just the things that are running there, but all of you and the kinds of activities that you are performing, the cognitive work that you are doing to keep that world functioning. And if we play with this a little bit more, we end up with this kind of model. The model has a line of representation going through the middle, and you interact with the world below the line via a set of representations. Your interactions are never with the things themselves. You don't actually change the systems. What you do is you interact with a representation, and that representation is something about what's going on down below. You can think of those green things as the screens that you're looking at during the day, but the only information that you have about the system comes from these representations. And what's significant about that is all the activities that you do, all the observing, the inferring, the anticipating, the planning, the reacting, the modifying, has to be done via those representations. There's a world above the line and a world below the line. And although you and we mostly talk about the world below the line as though it's very real, as though it's very concrete, as though it's something, the thing, in fact, the big surprise is this. You never get to see it. It doesn't exist. In a real sense, there is no below the line that you can actually touch. You never ever see code run. You never ever see the system work. You never actually touch those things. What you do is you manipulate in a kind of, I don't want to call it an imaginary world because it's real, but you manipulate a world you cannot see via a set of representations. And that's why you need to build those mental models, those conceptions, those understandings about what's going on. Those are the things that are driving that manipulation. It's not that world below the line that's doing it. It's your conceptual ability to understand the things that have happened in the past and the things that you're doing now and why you are doing those things, what matters and why what matters matters. Once you adopt this perspective, once you step away from the idea that below the line is the thing you're dealing with and understand that you're really working above the line, all sorts of things change. And what
I can't deliver that any faster. And this talk, when I saw it in 2017, changed the direction of my career. I found myself working for reasons I ended up working at New Relic, who were in the Snafu Catchers Consortium that these two folks were leading in the sort of second round. I didn't know that at the time I joined. I had seen the talk, then I got hired about a year later and found myself working with these folks. Their grad students were studying our company and a couple of others and developing more material in this. So the two people that are on stage there are Richard Cook, who was speaking, and David Woods, who is not speaking in this segment, but picks up where Richard leaves off there. They're sort of my two resilience engineering heroes. David Woods is probably one of the two main figures in the creation of cognitive systems engineering and then moving into resilience engineering. And Richard Cook was a partner with the three of them. There's many other folks' names who deserve credit, but I'll put their names out there as sort of the starters of this project. This guy, David Woods, was a young PhD in psychology when he was invited to do an analysis of the 3 Mile Island disaster. And that's where this whole discipline starts. And I'm going to not cover all of that, but the reason for mentioning it is to say the discipline grows out of safety sciences and global scale catastrophes, and what humans have to do to cope with that kind of pressure and how that contributes or not to the design problem for, like, he went on to try to design better control panels for a nuclear power plant as an early part of his career, and also went on to analyze the Challenger disaster and the Columbia disaster, and was probably behind the scenes talking to people about Fukushima. And anyway, and Richard Cook is interesting. He's an anesthesiologist, at least as the time he presents himself on this stage. It's, but I bring his person to your attention because I know that this community likes polymaths. Before he was an anesthesiologist, he was working for CDC, which is the company, for those of you who don't know, that Seymour Papert came out of and designed the first Cray computers. And so the first one was sold to NCAR. My dad was a salesman in the area, and I got to see it shortly after it had been installed. So there's some fun connections there. But he was a computer geek before he was an anesthesiologist, and then presented himself to the software community later as just this simple country doctor. And can explain our systems to us better as of 2017 than we understand for ourselves. So this is a huge idea. It's changed my career, and it fired me up about resilience engineering. Let me bring my next, let's see if I can get my buttons. Okay, we don't need to play it.
We start out with this view.
There we go. Here's the third big idea I wanted to bring to your attention. These three diagrams come from a paper whose I'm calling flight deck because I live in the 21st century. The original title is How a Cockpit Remembers Its Speeds. This is from '95 and is an evaluation of the takeoff and landing procedures for commercial airlines at the time, mid-sized commercial airplane, specifically a McDonnell Douglas 80. But these are diagrams from the paper. The premise of the paper is describing takeoff and landing. The thing about a commercial aircraft is it flies faster most of the time than it can go to take off or land. It has to fly slow during takeoff and landing. It has to fly fast between takeoff and landing. And so the planes are built to change the shape of the wing to accommodate different airspeeds. So the physics is pretty straightforward, but complicated calculations. The weight of the plane and the airspeed and the shape of the wing combine to determine how much lift you have. It's really the airspeed and the shape of the wing give you lift, and they have to be overcoming the weight of the plane. So if you get the settings wrong or the airspeed wrong, the plane doesn't fly and bad things happen. So this ends up being a safety critical change at takeoff and landing is how they cycle through these four positions of the wing. So as you're flying and before the bell goes off, the pilots are in the cabin and they're looking up stuff in a book to figure out what speeds today they need to be adjusting the wing. Because sitting and doing the math while you're descending will take too long, right? It's too error prone. So the cockpit has a deck of cards, which is what this thing on the left represents. And there's the fuel indicators includes a calculation built in that's real-time reporting about the gross weight of the plane today. So that changes on, it depends on how much baggage you have and how many people are on board, right? And how much fuel you've burned since you got here. So there's some built-in calculation in the dashboard for what's the weight of the plane. Based on the weight of the plane, they can pick the right card, and the card then tells them what airspeeds they have to care about. And with those airspeeds, they set these little bugs on these are just little plastic nibs on the edge of the airspeed indicator. There's two airspeed indicators. Both the pilot and the co-pilot have a back and forth conversation about how they set those four bugs so that there's redundancy in the system. And the joint result is when you're actually descending, one of the pilots has got their hands on the control, they're paying attention to the wind and where they're lining everything up. The other one can be watching the position of the airspeed, and then I don't know which one adjusts the shape of the wing. It's probably the one who's watching the airspeed indicator adjusts the wing, while the other guys, got the plane lined up with and everybody lands safely. This happens every takeoff and landing, at least in the 1990s. Tech's changed. There may be some other things going on, but my guess is humans are still involved in this because there's so much judgment in all of the decisions that are going into doing that process safely. Now, there may not be, they may have a computer instead of a deck of cards to help with some of that calculation. But here's the thing that blew my mind when I read this paper and finally got it. This is two humans and a whole bunch of artifacts thinking together in a safety critical operation. So the cognition that's happening is distributed between two humans and all this stuff. And some of that stuff includes these stupid, simple little plastic bugs that are on the edge of the thing. And it turns out what that does is changes the work, the nature of this work from hard calculation. I mean, it's simple calculus. I don't think you have to do heavy calculus to do the math. But you, instead of calculating or memorizing, you just are doing a perception task of is the airspeed crossing the line of that bug. No cognitive effort required for our visual cortex to decide, okay, yeah, time to change the shape of the wing, right? That's a really cool thing. And it helped me understand, oh, cognition's way more than I thought it was. And this kind of a design, there's some thought in there that's super interesting. So those are the three big ideas I wanted to bring. Let me hang them together to try to, I've talked about the three. There's three others that are like, I'm aching to also talk about, but I'm going to stop myself because I think that there's enough here that we could probably have some conversation. I can share the slides and I've put links throughout to reference the stuff that I've been doing. One of the things to talk about while I'm here, there is a new foundation in resilience engineering in software specifically. A bunch of my professional network are doing that work, and I'm known in that community. I can introduce you. There's an effort to try to create a movement in the software industry through that community. And then there's a reading list. If you're a reader, I have a hard time reading. I have not gotten through this reading list. And there's 40 years of material, but if you read quickly, there's a ton of other material. And then of course, I'm interested. Part of the reason I wanted to put this here is because I needed to bring in more than a reading list. Like I could have just come in and said, resilience engineering is cool. You'll read this stuff and you'll get a much better intro. It's not an accident that I picked this Gestalt perception thing, because a lot of the work of resilience engineering is trying to connect the insights from all this research around whatever your current context is to make better design decisions. And that turns out to be a hard problem all by itself. But I think that there's some interesting opportunities for conversation today. I hope you'll agree to just say, well, where is the work is done with joint cognition? Or where's the joint cognition with the line of representation? Or how do what pops out if we're looking at all three of them? And I'm keenly interested if you see any application of these ideas to your own areas of work. And that's sort of, I'll leave it there and see if anybody's got questions or wants to start something.
Well, the work is done. Piece is interesting if you think of it from a built environment perspective. So you've got the whatever the context of imagined, disclosed, prescribed, and done. And in a built environment, you've got planned, designed, and as built, so to speak.
Right.
And if you're dealing with an incident and you've got information that says this, but it's as built this, then you say, well, the fire alarm didn't go off, or the thing fell down because it wasn't strong enough, or whatever it is. So it's almost like the work is done requires a remote sensing kind of thing, or something where you've got your line of representation. Well, I've got this stuff, but if you don't have the right stuff, you aren't solving the problem.
Yeah. If I can deepen that idea a little bit, one of my jobs on these last three was in a business that does software for contractors. And Procore is the name of the company. If you were going to pay a subscription for that, you're probably a contractor of fairly large projects. And the whole structure of that business is a continuous stream of renegotiating contracts, because what you learn in construction is that the design didn't meet the reality of the construction. So one of the beautiful things about being in this community, if you have any architecture or construction background, is work is done versus work is designed. Like that's the business of building. And anybody who's doing architecture runs into that, and they're part of the fights and renegotiating those contracts.
Well, the
right?
same thing with code down the level. It's like somebody put this library together and it was crap.
Yeah,
But people are all using it.
yeah,
Or if it's a building and you actually, I don't know, point a LiDAR at it or whatever, you say, oh, that doesn't look anything like this CAD drawing, you know? Or there's some piece of it that doesn't look like it. And that has implications for maybe just the amount of space that it has, or it could be for something structural that's a big problem, then it
Right.
falls over later. And so
right.
that work is done is like, how do you prove what work is done?
Right.
Your Venn diagram was interesting for me because I ran Sun Microsystems' first internet development organization.
Did you?
And how that intersects with what you're talking about is we were at the transition from software delivered with a book that you looked up how to do stuff,
Yeah,
and software delivered over the web where there was no book and it had to actually be intuitive, you know. And what we learned really, really quickly, because the group at Sun, we were the internet company and we were doing a lot of the early prototypes for online banking or logistics or any of those things, is that that diagram, people didn't understand it, right?
Mhm.
And what they really didn't understand is that people lie. They don't mean to lie, but they tell you the rosy picture of what they do. So
Exactly.
it doesn't help you to make a better system by interviewing the users and saying, well, what do you think? Or how do you use this? And we built the first serious UI UX usability lab in
Yeah.
Silicon Valley as part of this transition to the web. And we also adopted a set of techniques where we didn't ask them anything, we observed them, right?
Yes.
So that we got much better software when we stopped listening to people and started just watching. We were trying to get to work as done
Yeah,
directly. The point of me covering this is that my wife knows one of my biggest mantras when I use software is, doesn't anybody effing test this stuff? Right? And we learned a ton of stuff. This is 1994, right? 1995, that we're still screwing up today. I mean, most software out there is horrifically bad from a UI/UX standpoint.
Yeah.
Basic stuff. And it's because they still don't understand this.
Yeah.
I don't know if that was part of what you were trying to get across, but
it's
boy,
definitely.
that really,
You and I could
that's
probably-
changed my life.
We could riff on this problem for a long time, because this is one of the, so. Another thing that's changed, and it's exciting to talk to somebody who was at Sun at the transition from shipped software to networked software.
Well, and I'm also
Right.
the guy that brought Oak out of Sun Labs, which was later named Java.
Yeah.
Oh, you're one of the first people I.
I know, oh, yeah, I was paying attention early.
So your stories are interesting.
Yeah, so a big difference between, so I think the software industry is still sort of, I guess I'm gonna call it drunk on the idea of agile software development when we were still shipping floppy disks. That there's this, I deliver the software and then running the software is the customer's problem, right? But anybody who's writing software today, they're operating the software for their customer. And that's another reality that folks haven't caught on to. And so,
Although financial models are evolving to say as a service versus this thing. So it's like, we contract for storage, we contract for transactions, we transfer for these things versus, and then you are actually doing it and the person just wants the result.
yeah, and I mean, I have other stories about the trick of running incidents with a vendor between the software. Like one of the things, if I go back, I have this on a different slide. I brought a larger version of this diagram. The conversation between the humans above the line gets harder when there are legal barriers and a support queue. So if I'm as a business, I've decided to move all my software to the cloud. And maybe I'm using, do you all know Kafka? If I start riffing on, so Confluent, I have been a customer of Confluent at several different companies. You outsource the management of the broker to Confluent, but you still are running the producers and consumers in your own cloud. So the machinery below the line are wired up, they're networked. And probably even in the same zones inside of AWS or GCP. But the organizational distance for talking about a problem that crosses those boundaries is extremely hard to bridge. And the engineers in my company who are running into a problem will try every lever in reach in the producers and consumers before they convince themselves it must be the broker that's causing this problem. And then they'll learn that they don't know how to use the dang support queue to get a hold of Confluent. And so now they've gone 2 hours, none of their levers are working, the impact is still happening, they're not quite getting it done, and they don't know how to call for help. They figure out how to call for help, and when they call for help, the tech finally shows up in the call and asks for logs. You thought the hero was going to rescue you, and the hero doesn't have enough context to answer your question. So the vendor stretches that incident out. And all of us in internet scale businesses are increasingly in that problem space and also don't know it. Because when the leaders who are far from the work is done were outsourcing to run in the cloud, there was all sorts of reasons that made sense. And none of those reasons included when we have an incident, it's going to get harder. And those coordination challenges get harder, and we're all in that business now. So this is part of why I think the resilience engineering as a practice is so important. I think we're in, as an industry, we're in for some hard incidents to start to learn that we've got to get skills in navigating technical support into engineering curriculum. Right? It's not just writing code, I've got to navigate the support apparatus.
So the culture, resilience engineering culture is alive and well in some industries. So before I was at Sun, the Navy paid for my education, and I flew fighter jets off aircraft carriers for 3,000 hours. And your picture of the MD-80 and the landing part, that's interesting, and I'm not sure if you picked it because of this, but that's where we lose most airplanes.
Takeoff and landing.
No, takeoff and landing when we're trying to solve that problem.
Oh, no kidding.
And the actual problem that causes us to lose airplanes is those bugs only work if your wings are level. As soon as you change the lift vector, it changes the entire equation. And all of those
is the certain air density or some weather.
Well, air density doesn't matter because it's indicated airspeed. So that's taken care of by the instrument. But as soon as you roll the airplane, which we do all the time coming into airports, return. In that particular problem has gone away in the United States Navy because of the type of engineering that you're advocating. We lost tons and tons of airplanes early on the approach turn to the carrier. Because that doesn't work, right? That math doesn't work. And you would stall the airplane and you're only 500 feet above the water. So it's a couple seconds and you're in. The way I learned how to fly a fighter was not that way. It was with angle of attack. So we have an instrument in the airplane that is fundamental to the way the wing works, because then when they went back and looked at the root cause for all of these incidents, they discovered what you described, and they said, let's not do that anymore. And can we go back and involve the physicists and the aerodynamic, the aero engineers, and figure out, can we somehow communicate to the operator, the pilot, that the wing's not flying anymore, or it's flying optimally, or it could be flying better. And so in a Navy fighter, we come into the carrier, we never look at the airspeed. We look at the angle of attack. The angle of attack is the relative wind to the wing. And it gives you optimum amount of lift for any configuration if you know what angle of attack you want to hit for that wing, right?
So I totally can hear that the critical thing that's needed in that circumstance is for the pilot to have a model and instruments that support the model of what staying in the air means. An angle of attack is a better model than these bugs on airspeed.
Well, they don't
For-
even need a model, they just need a parameter to
Mhm.
follow. The interesting part is 50 years later, after we adopted angle of attack, that's now the hottest new instrument in general aviation. It's now being put in all these little airplanes out here that
Mhm.
fly, and it's still not in airliners.
Interesting.
So try to explain that with
Yeah,
the culture
There's
we
still
have.
floppy disks on an AWACS.
yeah,
Yeah,
yeah. The resilience engineering grows out of safety critical stuff.
Yeah.
And so it's absolutely connected to the Navy. One of my favorite quotes in this space is, I'll have to look for I'm not going to go search for it now, but there's a description of flight operations on an aircraft carrier. And it's kind of hysterical how complex the problem of getting planes safely on and off of an aircraft carrier.
challenging.
But the punchline at the end is you're staffing this with mostly with 20-year-olds who've never seen an airplane.
Average age 19, average education level, sub high school.
Yeah.
Graduation.
Um,
So the thing, I've crossed over to the software world, and that culture doesn't pervade the software world, I think, because it's not a life and death, perceived as life and death problems, so it's very costly to go off and do all that thinking.
Yeah.
Right?
Yeah.
It's not part of the normal software design process. Even basic UI UX isn't part of the normal software design process.
Yeah.
So I would argue that it's cultural.
Yeah,
We know how to do all this stuff.
Yeah.
The culture doesn't support it for some predictable reason. So if you want to change it, you have to do something very, very hard for engineers, and that's change culture.
yeah. That's what I'm trying to do in my job right now.
Yeah, good luck
And
with
I'm
that.
skeptical about whether I'll succeed, so, but it's I think there's a challenge in the software business, so like, the symptom you're describing is exacerbated even in the last 2 years, because all the big software companies threw away 20% of their staff. And a big chunk of what I saw go was, the QA engineers and UX researchers were the more optional, and also middle management. Like the most recent rounds of layoffs, they threw a lot of middle management away. And there's a lot of hype and hope on what AI is going to bring and solve all these problems for us. I'm deeply skeptical because I've just spent the last 7 years coming to really appreciate what expertise really means. And how hidden expertise is. I'm gonna go back. I knew I couldn't resist this. That law of fluency. Oh, I clicked, and then the law of fluency and expertise is an important one. And it connects to the fact that I'm a martial artist, right? I've got all this experience trying to learn a really complex, subtle expertise from people who are way more expert than me for a lot of years. And I know how hard that problem is. And this is in a fully embodied kind of practice. But in software or in any business, the expertise you're looking for is often really mundane. But as soon as somebody's an expert in it, it's like it moves out of being frontal cortex that you can really talk about and becomes like in the brainstem, and people just do it naturally. So the work looks really easy when an expert's doing it because they anticipate the problems and then you don't see the problem. And so from the outside, if you don't have the expertise, you don't understand why, but whenever I gotta find a name from somebody else's company. Whenever Paul shows up, the incident goes smoothly. And we can't really explain why, but everybody's relieved when Paul arrives because it all goes easier when Paul's there. And it's hard work to actually discover what it is that Paul's got that the rest of the org doesn't have, because it becomes subconscious or close to subconscious. And then there's this other feature, and this is another one where I love being in an architecture context. Ray McCall was the other big computer geek at the College of Architecture and Planning when I was there. And Mark and Ray both would have conversations. I would just eavesdrop about how computer-aided drafting software of the 90s was not a design tool and didn't actually help you with design. And Ray was really fond of saying, you know, if you ask an architect what they do, they'll give you all kinds of poetry. If you film them, what they do is draw and draw and draw and draw and draw. And this was your point about the UX. I went through a UX thing with Sun probably in the early 2000s on a search thing. And one of the things I said, you should tell me the search results. I don't see them anywhere. They were literally right there on the screen. I couldn't see them because I was skipping past that because I looked like where an ad should be. And I just ignored it. Anyway, what people are doing with expertise is subtle. And if you're not watching what they're doing, you can't discover it. So this is another place where the communications break down, that they're at the sharp end. Even if I ask the expert, how did you know? There was a fun story from one of the incidents. Somebody asked, so how did you know so early that it was Cassandra? And the expert said, I always look at Cassandra. It's the first place I look. And let me tell you about the 20 other times it wasn't Cassandra. Well, that's actually pretty interesting. In this incident, that habit of always looking at Cassandra featured in a faster remediation, but it turns out that was luck or expertise, because that component is fragile, and we had an expert that knew to look there and would always check there.
So one of the other things we learned early on was that you can't test intuition with people who have seen a UI even once. So you know, and you know this because one of the worst interfaces in the world is Microsoft's, right? Things buried down in long lists of right, and so if you have a flawed UI, if people learn how to use it once, then you won't ever see that flaw again in your testing, right? So you have to keep going and getting, and it shows up over and over and over in design because, for example, expertise in flying. You can have an airplane that is a terribly dangerous airplane to fly. But if somebody gets enough experience in it, you never see it, right? You see it when the student transitions to that airplane the first time. But maybe after an hour or two,
they've adapted.
But where do you have all the accidents? In the first hour, right? And in software and web software, where do you have most of the loss of customers?
Yeah.
It's in the first use of the software. They reject your company because, you know, it's Levi Strauss, you wanted to buy jeans, you can't figure out how to buy jeans, screw Levi Strauss, I'll go buy them from Wrangler, right?
Yeah.
By the way, those are the two companies we found this out on. So it's interesting, you know, how do you get past these knowledge points and say, how do I create a better design group, or how do I create a better company, you know, and not miss this stuff? And I think we've learned it over the years. It's just we don't apply.
Yeah, so here's the answer that the resilience engineering crowd say: pay attention to your incidents. So the thing that happens,
Absolutely.
you can't ever escape the incidents because the world's just too complex for you to design incident-free software. That insight is already novel in the software business. We keep trying, and with the belief that we're going to have incident-free software. But I think folks are starting to catch on. Yeah, that's not a thing. So after the incident, and not after every incident, because the investment is still too high to do after all of them, but after a few of them, you want to do some work, to have a team of people who know how to elicit expertise from the people who are involved, to do some interviews with the skills are cognitive task analysis and cognitive interviewing. And then there's a thematic analysis after you've collected evidence from a whole bunch of people. This is all qualitative research that the software business is also allergic to, because it's not quantitative data I can jam into a spreadsheet. So when I bring qualitative insights, the instinct for the leaders that I'm talking to, and I don't want to, it's too easy for this to be a story of me complaining about leadership. I actually understand something about the cognitive challenge that leaders are in, and they're confronted with too many decisions. They need the dashboard of numbers to be able to cope with the volume of decisions they're making. But the stuff I'm presenting requires some more time to think about. So, but the practice of learning from incidents, the premise of it is, if I pull on the threads in a complex system, I will find the most tangled parts of the system that are contributing to the problems in my business. And one of the challenges is that everybody already knows what those are, and they're already choosing to not invest in those problems. So the hypothesis that I have not yet seen deliver is that if we keep collecting evidence to say, yep, we had another incident that involved Cassandra. Oh, it was Cassandra again. Well, this time it wasn't Cassandra, it was the load balancer, but next one was Cassandra. Oh, load balancer, Cassandra, the database, the other persistence store, like all of these high volume things are the things that keep being the tangled mess that we can't, yeah, we know we've got a re-architecture problem there, but we're going to put that off a little longer. Like that's the practice that shows up. And what's actually kind of cool is that business keeps running. Like there's some sense in which the decision is not necessarily wrong, but it's really hard to see when you've crossed into the territory where that one's really going to threaten your business. So what I think I'm trying to do with my enthusiasm for resilience engineering and then coming to you fine people is to connect the dots between this practice about learning from incidents as a design activity. Because I think business knows they're doing software design and they know they're doing as little as they can on reliability because that's a story about profitability. They'll do as much reliability as necessary and then as much as they can invest on the other side of it. And I think if I can connect the dots to say, here's how you design the next round on your software more connected to reality, that might get us better software. And it's still a hypothesis because I have yet to actually convince leaders to change their direction in that particular way. And it has worked in the Air Force and the Navy. I know that there's stories in the I don't get to hear the specifics because it's all military secrets, but there's stories that military has adapted. We have this vision of the Navy as a command and control structure, but they're one of the most adaptive leadership structures of any large organization, in part because they've got some, I think there's also a long tradition in the Navy that founds a lot of the practices here, not the least of which is aircraft carriers. I've shifted into rambling and not conversation.
Well, I think you're learning from incidents, then is the logs, is the collection of data regarding things that are going on so that you can go back and say, hey, let's replay that.
Yeah.
Or let's say, oh, this happened 17 times in the incidents and this didn't happen in the incident, whatever it is. Like you said with the tech guy, I need to know what's going on, give me your logs,
Yeah.
How do you do that? And if you don't build that into the tool, well, there's no motion sensing, there's no data converse, whatever it is that you didn't capture that.
Yeah.
So you don't know. It's
Yeah.
like a black box.
Yeah.
So I think a lot of it is back to culture. And so one of the things I worked on in the Navy was when we have a failure in a component in an airplane. If that failure, then we go back and compare the mean time between failure. If that failure happened much earlier than the mean time between failure, then we have to do an engineering analysis of it.
Mhm.
And those culturally were viewed as nerd exercises and weren't paid attention to. And as a result, they would take forever to get done. They because they were complex. You had to look at the thing and then you said, is that a material problem? Is that a software problem? What is it? Send it to those experts. Then they have to decide, no, it's not, send it to these other experts. And you can imagine that most of those got lost.
Mhm,
Until we lost a couple of airplanes and killed some people.
mhm.
And then we went back and looked at the process, and I happened to get tagged to look at the process. And found out that the importance of getting the answer got lost when that question was pushed into a
Yeah,
diverse organization. So we solved it by, basically looking at what you're advocating, looking at the logs, looking at the log of the movement of the engineering
request, yeah.
investigation
yeah,
through the process and saying, and putting time limits on and saying, if this is important, if we lost lives, we need an answer in 90 days, right? And let's track it.
Yeah.
And then we automated the track process. And now it happens and we get answers really quickly and it's saved lives and all that stuff. But I think we learned some things that are valuable in that, and that organizations, when you start going down in levels of hierarchy, they lose the big picture pretty quickly. And now it's just work that comes across my desk. And so I think, you have to go back and really start looking at root causes and culture and how do you deal with real people and real organizations to change the way they behave.
Sorry, I'm
People
about to
are
close
hovering,
it.
yes.
People are hovering. Okay, there's a faculty meeting here starting in 1 minute. So sure, go ahead when I pack out.
Just brief remark on the culture. So I'm a social scientist. I would underscore the culture issue, because if you're flying in an airplane, you have at least for the crew members, but also for the other members, a high interest in securing the standards.
Yeah.
And that's getting aside.
Very high.
Interestingly, not even software companies, even if you take a look at medical doctors, where you
Yeah.
would think they have an interest in saving lives of patients,
Yeah.
they don't care so much about the rules. There are many instances where they don't
Watch them.
wash your hands properly,
Yep.
disinfect them, because it's the patient that's dying of them. But in culture is certainly a crucial factor in explaining.
yeah, it's just,
And self-interest.
absolutely.
Yeah.
Thank you so much for
Thank
the
you.
time and attention. I enjoyed being here.